Alright, welcome to video number 27. We're going to be talking about force and then also momentum, their relation with one another, and then also the components of each of them. So let's start off with writing both of the equations. Force is equal to mass times acceleration. We also have momentum, which is, and here we see the first relationship. If you remember, the derivative of velocity is actually acceleration. So in that way, we see derivative of momentum is actually the force being exerted on that certain object. You see how mass isn't changing though? This is because mass is constant, so it would stay, if you were trying to measure the force of one object with this one certain mass and then try to find the momentum of that same object, the mass would be constant. So the masses are the same, obviously, here. All right. So now we're going to look at problem number 27, and we're going to see how we can actually use this relationship to solve the problem. So the problem number 27 gives us a function, gives us a graph. The x is time, and the y is force. All right. Okay, now that we have it, I'm going to read the problem. So the graph above shows a variable force F that acts on an object as it moves along a straight line as a function over time t. What is the change in momentum of the object from t2, so from here, to t4? So we want to know the change in momentum from these two. Now if you remember, derivative of momentum is equal to force. So we're going to use that relationship, and we are going to use the integral because we have force, but we want to find momentum. So that we're going to use the integral of that. And then also, just a little quick background if you didn't know, integral also, basically what it is you can take the area beneath the line, and then here we have the domain, which is 2 to 4. So with this problem, we can actually count up the units really easily. So we have 1, 2, 3, 4, 5 whole units, and then we have a half and a half. So that would equal to 6. And then momentum would be given in kilograms meter times meter per second. So our final change in momentum from t equals 2 to 4 is 6 kilograms meters per second.